Alright, for today's class, we are going to look at the empirical and molecular formula. By the end of this class, you should be able to determine empirical and molecular formulas from experimental data. But first, we need to understand what we mean by empirical formula and what we mean by molecular formula. The empirical formula, that is the simplest formula for a compound. What I'm saying is that the empirical formula does not show the actual number of atoms of each element in a molecule of the compound. If the empirical formula does not show the actual number of atoms, that means the molecular formula shows the actual number of atoms of each element. For example, glucose. The molecular formula for glucose is 6 carbons, 12 hydrogens, and 6 oxygens. The simplest formula, or what we call the empirical formula, will be 1 carbon, 2 hydrogens, and 1 oxygen. Now, let us look at an example where we'll be predicting the empirical formula and molecular formula from mass percentage composition. Right? The statement reads as follows. A compound has 40% carbon, 6.67% hydrogen, 53.33% oxygen by mass, and its molar mass is 180 grams per mole. We are to predict the empirical and molecular formula of this compound. Now, the assumption is that we have 100 grams of our sample, right? And that the mass percentages are equivalent to the mass of those elements, right? That is to say, 40% carbon is equivalent to 40 grams of carbon. 6.67% hydrogen is equivalent to 6.67 grams of hydrogen, right? From there, you are going to convert those masses to moles. To get moles is going to be mass divided by the molar mass, right? Or the mass number, right? So for carbon is going to be 40 grams divided by 12 grams per mole, giving us 3.33 moles. You're going to do the same thing for hydrogen and oxygen. Now, those numbers, 3.33 moles, 6.67 moles, 3.33 moles, they become the subscripts for the tentative chemical formula. That is 3.33 carbons, 6.67 hydrogens, 3.33 oxygens. Now, into step 3, you are going to divide each of the subscripts of the tentative chemical formula by the smallest subscript, that is 3.33, and you are going to round off any subscripts that differ only slightly from whole numbers. For example, 2.99, 2.98, 2.01, 2.02, and so forth, right? But in cases that you have a decimal number like 2.46, you need to find a whole number that when you multiply that decimal number by it, it gives you a decimal number that is closer to a whole number, right? So when we divide each of the subscripts of the tentative chemical formula by the smallest subscript, we are going to have 1 carbon, 2.02 hydrogens. Remember that we need this number to become a whole number, and 2.02 is closer to 2. Hence why we are going to have 2 hydrogens and 1 oxygen. So the empirical formula becomes CH2O. That is 1 carbon, 2 hydrogens, and 1 oxygen. From there, you are going to calculate the molar mass, which you are going to use to determine the molecular formula. So the molar mass becomes 12, that is the mass number of carbon, right? Plus 2 hydrogens times the mass number of hydrogens, which is 1, plus 16 for oxygen, giving us a total of 30 gram per mole. Now, to determine the molecular formula, we are going to divide the molar mass of the compound, which is 180 gram per mole, by that of the empirical formula, which is 30 gram per mole. So N becomes 180 gram per mole divided by 30 gram per mole, giving us 6. From there, to get the molecular formula, you are going to multiply each of the subscripts of the empirical formula by N, giving us a molecular formula of 6 carbons, 12 hydrogens, and 6 oxygens. That is the end of our class. Thank you.